Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 8 to the power of x is equal to 32. And make sure to stay to the end of the video for a bonus problem that is similar to this one. So what I'm first going to do is I'm going to rewrite 8 here as 2 over 3. 2 to the power of 3, because 8 equals 2 to the power of 3. So now I have 2 to the power of 3 to the power of x is equal to 32. Now if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 3 to the power of x, this is going to equal 2 to the power of 3 times x. 3 times x is 3x, so I have 2 to the power of 3x is equal to 32. Now 32, this is the same thing as 2 to the power of 5. So now I can replace 32 with 2 to the power of 5. So now I have 2 to the power of 3x is equal to 2 to the power of 5. And remember, if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So for 2 to the power of 3x equals 2 to the power of 5, these two are equal to each other, so I have 3x is equal to 5. Now if I divide both sides by 3, I get x is equal to 5 over 3. Now another way of doing this problem, 8 to the power of x is equal to 32, is to take the log on both sides. So I have log 8 to the power of x is equal to log 32. And now an important property of logarithms is that if I have log a to the power of b, I can actually move this exponent b to the front of the logarithm. So this would actually equal b times log a. So log a to the power of x here, I can move my exponent x here to the front, so this is going to equal x times log 8. Now this is equal to log 32. Now I can divide log 8 on both sides. These two will cancel out, so I'm left with x is equal to log 32 over log 8. Now 32, that's the same thing as 2 to the power of 5, and 8, this is the same thing as 2 to the power of 3. So now I have log 2 to the power of 5 over log 2 to the power of 3. Now remember, log a to the power of b, I can move this exponent b to the front, so I have b times log a. So I'm going to do that for both of these. So for log 2 to the power of 5, I'll move 5 to the front. For log 2 to the power of 3, I'll move 3 to the front. So now I have x, So now I have x is equal to 5 times log 2 over 3 times log 2. Now these log 2's can simply cancel out. So I'll be left with x is equal to 5 over 3. Now to check, we have a to the power of x is equal to 32. X is equal to 5 over 3, so I have a to the power of 5 over 3 is equal to 32. Now I can, a to the power of 5 over 3 is the same thing as the cube root of a to the power of 5, which is equal to 32. Now for a to the power of 5, that is equal to, I can plug that into my calculator here, 32,768, and the cube root of that is 32. So 32 equals 32, meaning x equals 5 over 3 is right. So we have 27 to the power of x is equal to 9. And now what I'm first going to do is I'm going to simplify 27 to the power of x a little. So 27, this is the same thing as 3 to the power of 3. So what I'm going to do is I'm going to substitute in 3 to the power of 3 for 27. So now I have 3 to the power of 3 to the power of x is equal to 9. And now if I have something in the form a to the power of m to the power of n, this is actually equal to a to the power of m times n. So 3 to the power of 3 to the power of x, we can think of a as 3 in this case, m as 3, and n as x. So this would be equal to a to the power of m times n. So 3 to the power of 3 times x. 3 times x is simply 3x, so I have 3 to the power of 3x is equal to 9. Now 9 here, this is the same thing as 3 squared. So I have 3 to the power of 3x is equal to 3 squared. And now another property of exponents is that if I have something in the form a to the power of m is equal to a to the power of n, then this means that m is equal to n. Because if the base is here, these two are the same, then this means the exponents are the same as well. So now for 3 to the power of 3x is equal to 3 to the power of 2, this means that the exponents, 3 to the power of x, 3x and 2, these two are the same. So now we have a simple equation, 3x is equal to 2. So now if I divide both sides by 3, these two cancel out, and I get x is equal to 2 over 3. Now to check, I'm going to plug in 2 to the x equals 2 to the power of 3 in the equation 27 to the power of x equals 9. So now I have 27 to the power of 2 over 3 is equal to 9. Now to solve 27 to the power of 2 over 3, this is the same thing as the cube root of 27 squared. Now 27 squared, that's equal to 729. So now I have the cube root of 729 is equal to 9. And the cube root of 729 is equal to 9. So I have 9 is equal to 9 because this is right. We know that our solution x equals 2 over 3 is right. All right. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 4 to the power of x plus 4 to the power of x plus 4 to the power of x plus 4 to the power of x equals 1024. So what I'm first going to do is I'm going to factor out 4 to the power of x from the left-hand side of the equation. So if I factor out 4 to the power of x, 4 to the power of x divided by 4 to the power of x is 1. And I'm going to do the same thing with the rest of the terms. So now we have 4 to the power of x times 1 plus 1 plus 1 plus 1. And this is equal to 1024. Now 1 plus 1 plus 1 plus 1, this is 4. And I'm still multiplying this with 4 to the power of x. And this equals 1024. Now, if you notice, these two have the same bases. And if whenever I'm multiplying exponents, let's say we have a to the power of m times a to the power of n, this is equal to a to the power of m plus n. So 4 to the power of x times 4 to the power of 1, because 4 is equal to 4 to the power of 1, this is going to be equal 4 to the power of x plus 1, because x in this case is m and 1 is n. And this is equal to, I'm actually going to rewrite 1024 as 2 to the power of 10. So now what I'm going to do is I'm going to change one of these bases so that they're the same as the other one. Because if we have two same bases, then we could just set the exponents equal to each other and solve. So what I'm going to do is I'm going to convert 4 to 2. And 4 is actually equal to 2 squared, right? So I'm going to replace 4 here with 2 squared. And this is to the power of x plus 1. This is equal to 2 to the power of 10. Now, if we have an exponent in the form a to the power of m to the power of n, this is actually equal to a to the power of m times n. So we have 2 to the power of 2 to the power of x plus 1, and this is going to equal 2 to the power of 2 times x plus 1 in parentheses. Remember, it's going to be in parentheses. And this is still equal to 2 to the power of 10. Now, we're going to have to distribute this 2 to all the terms in our parentheses if we want to multiply. So now 2 to the power of x is 2x, and 2 to the power of, 2 times 1 is 2. So we have 2 to the power of 2x plus 2, and this is still equal to 2 to the power of 10. Now, if you notice, both our bases are the same, meaning our exponents have to be the same as well. So that means that we have 2x plus 2 is equal to 10. Now, if we subtract 2 on both sides, we get 2x equals 10 minus 2 is 8. And now if we divide by 2 on both sides, we get x equals 8 divided by 2 is 4. So 4 is our answer.